Good afternoon, and today we're going to be taking another look at the SLT7ME multi-standard Betamax video recorder. Now, last time we left this, we'd identified a problem with the PSU. So basically what was happening was the PSU was not coming out of its standby mode. So what I did during the week was I purchased the following items. So I purchased two. I'm just looking at them now. So I actually bought four, but the machine only needed two. I bought two C898 transistors, which go into sort of bolt onto that heatsink at the back of the machine there. I think they are rectifiers or power output transistors or something like that. They are certainly sort of quite a heavy grade transistor and do have quite a large heatsink and a lot of heat paste going onto them. I also purchased a TL494CN switch mode controller integrated circuit. The reason why I purchased these was when doing some investigation online, I noted that those particular items were common failure points on this particular deck. Now, unfortunately, and a bit of a spoiler alert, it does transpire that replacing those items did not resolve my issue. So what I've had to do is actually do a bit more investigation and actually sort of, without a wiring diagram, try and work out how the power supply actually works. So on the top there is a distribution board which I've now removed, and that's got a number of fuses on it. And that distribution board effectively channels the relevant voltages out to other parts of the machine. There are some cables which appear to be specifically related to the clock and timer display, and there is a large connector that actually appears to be related to the actual deck function itself. So what I found was that if I applied a small voltage to one of those positive terminals on the main deck loom, I actually could partially energise the deck. I didn't have enough voltage from the source I was using to actually fully energise it, but it does show that there's something inside this supply that's not allowing the voltage to switch over and output to those particular cables. What I'm going to have to do is to trace back through the machine, that power supply, so actually get it on the counter and actually just trace back through it. What I'm doing here is I'm just marking the position of the chip, because obviously on the little ICs you've got a little notch in them which tells you the direction that the IC needs to be fitted. Actually transpires that when you've unsoldered everything, the IC position is actually marked on the circuit board, which is quite useful. Anyway, back to the troubleshooting. So what I'm going to have to do is to take the power supply actually out of the machine, hook it all together, so effectively get it hooked up to the clock, etc., and take it out of standby and try and measure the voltages from the point where power is coming into that unit to the point where power should be going out of the unit. In other words, those cables which are soldered into the power supply board. What that should hopefully do is it should give me an idea of where the fault is and what components I need to replace. Now, I've got a couple of capacitors on order which I will be replacing in this unit before commencing this troubleshooting, as these two large rated, high rated capacitors are also known to cause problems in this particular deck and power supply. With troubleshooting, I tend to operate on if it's a piece of equipment of this particular age, there are going to be weak points, and those weak points are probably going to have been documented by hundreds of repair engineers before me, a sort of small-time hobbyist, comes to the actual repair process or troubleshooting process. So there's no point effectively duplicating work because it's all been done before. you know, people have actually gone through the whole process of troubleshooting before. So in that case, it's just a case of reading up various forum posts, etc., asking the question, and occasionally, or sort of on multiple occasions, you do actually get an answer of what to start looking at. If it's a new fault that no one's ever seen before, then it will be at a point where I will need to start troubleshooting it myself. Incidentally, what I'm doing here is I'm trying to create a heatsink arrangement on that IC. So basically placing those needle nose pliers against the terminals that I'm going to be soldering, or the pins rather that I'm going to be soldering. So you take any heat away from the integrated circuit and you don't damage the integrated circuit itself. Now, it didn't actually take that long to apply the solder, so for the other side I didn't actually use the heatsink method, so I'm not sure if I've still got a blown IC, if I've accidentally blown it with the heat going through it. But I factored in I wasn't keeping the soldering iron on there long enough to generate too much heat into the pack itself. However, you never know. So that may be another component that I might have to replace again if it does appear to be, or sort of seem to be at fault. Now the heatsink itself is held on by it's held on by 4 screws. Actually, no, sorry, 3 screws. You've got an extra long screw which holds it all together, and then you've got these transistors which are held onto the metal mounting plates with a little bracket. Now I actually did start unsoldering the wrong transistor, so what I did was I just basically used that as an opportunity to reapply solder to that particular transistor, so you know, it wasn't a wasted exercise, and in the long term it's benefited me. Now what I did as well was I did take the time to clean up the heatsink itself and reapply some of this heat paste. Something that you sort of learn from dealing with IT equipment, specifically PlayStations, Xboxes, PCs, etc., is this heat transfer compound can dry up and cause actual failures which are heat related. So if you actually take the time to strip it down, it is a very prudent idea to actually reapply all of the heat compound. You don't need a huge amount. I just used a pea-sized amount on each mounting point for each transistor, and then just clamped it all together with the heatsink. So just splodged it all together. You just clean up any sort of surrounding stuff that comes out, and away you go. Now, it was a little bit of, unfortunately, a negative end to the work that I was doing here, but it's a good learning process, and you know, we do know that replacing just those components has not rectified my issue. So I am going to have to look a bit deeper into the supply itself and possibly take a look at, well, initially those capacitors that I've got to replace. If that doesn't resolve the issue, then we've got to start troubleshooting back, just to see exactly where the fault may be. Now I did use transistors which were a different number to the ones that were originally on there, but according to documentation I've reviewed, apparently those transistors are a direct compatible fit. So I'm not certain if that's the issue, because the power supply is exhibiting exactly the same behaviour as it did before I replaced those components. I have kept the original components, so if I need to put them back in again, then I will do so. But unfortunately, with a machine of this age, there will be a point where I may have to call a day on this particular supply and hold out for one turning up at some point. But not to worry, it's an interesting exercise, and certainly does help improve my knowledge of these particular decks and also these switch mode supplies. Anyway, if you have found this video interesting, don't forget to hit that like button and also consider subscribing for more upcoming fascinating hobbies. Thank you very much again for watching.